Hello,
Hello,
I'm Andrew Gerrand,
I'm Brad Fitzpatrick.
and this is installment 2 of Hacking with Andrew and Brad, or Hacking with Brad and Andrew, depending on
Both.
your directionality.
We're gonna write some code.
Yes, today we're going to do the client for the Go HTTP2 package. And so the basic idea is you'll get the same kind of interface as the Go HTTP client, but it will be able to make HTTP2 calls. And so the main part of the HTTP client is the transport, which is the interface known as round tripper. So it looks like this. It's very light on the actual interface definition, but it has semantics, which we want to preserve. It takes a request and it returns a response.
So right now the HTTP2 implementation is not in the standard library, but it will be eventually soon whenever the HTTP2 spec is standardized.
Yeah,
so right now it's on GitHub, Brad Fitz HTTP2, and right now there's just a server. So we're going to basically add a new file to this. Maybe it makes sense to break this up into a server and client package in the future, but I mean the main HTTP package isn't like that, and I seem to recall trying to split it once and it was a pain, so I think we'll just keep it.
Well, I think you need 3 packages then, because the request and response are shared. So here we are in the HTTP2 directory, and that's all of the stuff that already exists. I think we're in a clean state, git status says clean. So if I open client.go,
we should call it transport.go probably.
Okay, yeah. Package HTTP2, we can add copyrights and so on later.
Okay.
So where's a good place to start? A function that returns a...
Well, make the type transport to be similar to the HTTP transport type. And so with HTTP2, you have to negotiate up to it, and the server may not support it. Mm-hmm. And it basically only works over HTTPS in practice. Mm-hmm. So I think we should probably have a fallback transport that if we determine either based on the scheme, whether it's HTTP or Gopher or FTP or something we know we don't support, anything that's not HTTPS, we just delegate off to the fallback.
So there should be a field.
Maybe just call it fallback, and it's a HTTP round tripper.
Yep.
And now let's add a method round trip to transport.
We tried something different this time, where Brad is going to be using Emacs on his machine, and I'm going to be using Vim on mine.
Should we test the transition?
Well, I'll let you flesh this out. I'll just... that's this definition, right?
Mm-hmm.
All right.
Okay. So now you have to switch...
Yep. So now we're in... This is cool.
So yeah, we're using Screen, and we both have our computers connected to a shared machine, and we can hit keys to switch between them. Okay, so basically if the request URL scheme is not HTTPS, then we're just going to...
invoke the fallback.
Yeah.
But what if it's not fallback, we should use... If fallback doesn't exist?
Yeah, then we should probably...
You want not equals nil.
Or equals nil.
Ah, yes.
Unsupported scheme. And no fallback or something.
Maybe we should just use the default client.
Well,
no,
that's a little magical.
Well, we might have a constructor that gives a default one, right? So if we say like new...
Well, in practice though, no one's going to be using this thing.
Okay.
So I think we shouldn't have much magic.
Yep.
The magic will all be in the default.
Okay, we can do it later anyway.
Okay, you want to test your switchback?
Sure.
Good enough.
And so now we're going to do this the naive way. So HTTP2 connections are pipelined. You can make many requests and have many responses kind of coming and going. But we're going to do it in the most dead, naive way.
Which is actually the way it turns out curl supports right now. So we're going to have one connection per request right now. and then we'll refactor it later to have a separate Go routine running per host, and then like other requests coming in that are also to like the same host will merge in and use the same TCP connection. But to keep this video short, we're just going to do the quick thing first.
Yeah, so to open a connection, do we actually have anything that does that? We only receive connections so far. So
okay, we know it's HTTPS at this point, so you can open up a TLS connection to it.
Yeah, so
TLS dial.
And the host is rec.host, url.host.
Well, so there's rules about if you look at the docs for HTTP and look on the type request, there's a difference between whether it's host, what the precedence is between host and URL dot. So
for client requests, host optionally overrides
the host header to send. Otherwise, it's URL.host. So basically, we want to connect to URL.host.
Right. Okay.
But
that'll include the port, won't it? Yeah, it has host colon port
or host port. So you'll have to maybe do a split host port or see if it has a colon in it. But then it could be an IPv6.
Doesn't TLS dial just take a string?
It does take a string, but we need to have port 443 if there is no port.
Oh, I see. Absolutely. Okay.
And so the way HTTP2 is upgraded is you specify the next protocol that you want in the TLS handshake. So we need to specify in the we need an explicit TLS config for TLS dial, and we need to specify the protocol ID.
Okay. We can do that. So I'll just split the port first. Does that take an error? It does.
Port string. And if there is an error, then we want to say the host is just the thing, and the port is 443. No, you don't want to return the error. I think at this point we just assumed that it was a host name and it wasn't a host port. rec.url.host.
Yeah.
And the port is 443. No. Oh, I see what you're doing. Okay. Yep. So you can underscore out that port.
Yeah.
Else, no. How about this? Else, if there wasn't an error, then you host plus equals, the stringification of the port number.
Yeah.
Well, not plus equals at this point.
Oh yeah.
Sure.
Okay, so TLS config.
TLS config.
Can we leave all this blank?
Yeah, but except the one we can't leave blank is next protocol or protocols or something like this. Next protos.
Next protos.
And actually, if you switch over to my screen, I'll show you where the constant is.
Oh, I need to save this. Or can I?
No, I don't need this buffer. So there's this constant here, this next proto TLS. So currently it's H2-14, which is for draft version 14, which is what everyone's using in the wild. And all Google servers are currently advertising this protocol. And then when the spec is standardized, we'll submit that patch.
Okay.
So there's your constant to use, is next proto TLS. And then I think you add HTTP 1.1 after that for backup. But I guess that's implicit, so it doesn't really matter.
Okay. And then
And that's a pointer to a TLS config. So. And then recdial is takes proto first, so it's TCP in quotes, and then the config.
Like that?
Yep.
And with the host we have deduced. Whoops. And then that gives us a connection and an error, I believe. Is there nothing else? We'll just do that for now.
Yeah, it's lazy. And then, so now we're, okay.
Well, no, that's not right. So now we have a connection. We need to actually start writing frames to that connection. We need to take the request and encode it as a request
we
frame.
need to actually look and see if the remote host negotiated to HTTP2 or not.
Oh, okay.
So we need to look at the connection state, which means we need to do a handshake first. So there's a method. So this con, I may not name it con yet because that makes me think of net.con.
Okay.
But maybe just like tcon or something. Well, it's not. It's TLS con. Yeah, tcon works.
Yeah, there you go.
And so now we'll do a handshake. So that's the handshake method on tcon that returns an error. It's a method,
Oh.
not a function. a lot of
handshaking.
There we go.
Oh, that's it?
Yep. And we may run into problems here because we did. Oh, your TLS config has to have a the host name that you expect.
Okay. Is it host name? Server name?
Server name. Yes.
So
that's the name that has to be verified on the cert.
Right.
So now, yeah, exactly. You're gonna have to.
Okay, so we'll have
Adder is the thing. Then keep that unmodified.
Oh, we actually need it not hoisted.
You can move the config up and then just set it directly in the config.
Oh, yeah. Oh, no, because we're dialing with it anyway. This is fine.
Okay.
So, but if this fails, we need...
You need to set the host there. And port is 443.
Oh,
Yeah, exactly.
this is... Yeah. Here we go. What am I doing? Yes.
Get rid of that variable and just move the sprintf inside the dial. I'm glad we didn't do the Viper mode thing, or the evil mode thing.
Yeah, that didn't work.
We tried to use one editor and just use Viper mode or evil mode in Emacs so he could have VI key bindings, but
yeah, it wasn't.
We
wasn't
failed.
A thing. Oh well. So now we have a handshake connection.
Yeah. So
do
now
we need to verify host name?
No, I think handshake. I think we'll do that.
Most users may not call handshake.
Because the first read or write does it lazily, but we do need it.
Yeah, yeah. And checks. Do we not want to check the certificate chain?
Here, why don't you switch over to the other one?
So I'll just save.
No, I'm not going to look at it. I'm going to look at the HTTP1 implementation to see what we do there. So it's tls.dial. Do we not dial?
Is dial a method in config?
Dial TLS.
Where is that? Is it another file?
Connection state. Oh, okay. I guess we do handshake first and then verify the host name. So, yeah, might as well do that.
Well, you go and put it in the file. You just copied it.
Okay.
Actually, I can do that pretty easily. There we go. You'd think it would just do that, wouldn't you? Oh well.
We'll file a bug against AGL to fix the docs.
Yeah, or he could watch the video and maybe he'll know.
He's a busy man. He doesn't have time to watch videos.
Not these kind of videos.
Okay, so now we need to look at the connection info in the crypto on the tcon. If there's a method called like connection state or something. Yeah, connection state. There we go.
And what are we doing with this?
It has a field inside the connection state. So the method is called connection state and the return type is called connection state.
It's very idiomatic.
And there is a negotiated protocol, and negotiated protocol is mutual. And I don't know why it would be negotiated protocol. the string if it wasn't mutual, but let's check them both.
All right.
And also ask AGL what the difference means.
So
actually, let's bail on this for now, and let's try testing this against google.com to see what the state is. So why don't you just log printf the state? I think plus v is enough, but whatever.
Okay, plus
v. And panic. I don't know, whatever. Or return. Nil. Yeah.
Actually, yeah. We need something to test this.
Write a test, transport test. We'll just do a live network test for now, and eventually we'll fire up our own server and test our client against our server.
Ooh,
I know.
So we want T as a.
Let's use HTTP new request. So rec, error is
Sure.
HTTP new request. Get, and then HTTPS ip.appspot.com or something.
Sure, that's simple enough. Nil.
And transport, the 0 value is fine.
And then
Do round trip rec. Yep. Let's see what that does.
yeah, that's fine. We're not returning anything worth returning anyway.
Mm.
Oh, actually, we should log it.
Well, if there's an error. Probably fatal F because we can't proceed past that point.
That's true.
Oh, you copy pasted it from the docs,
Ah,
which didn't have HTTP on it.
whoops. All right. I didn't even copy paste it. I just typed it.
Mm.
What else?
It's
Can it use 443? Oh, it's a string.
Oh, that's cute.
That saves us a sprintf.
We'll be ready when we have string ports now. I guess we can do string ports sometimes.
Okay, now try it again. Undefined state. Oh,
Oh, you deleted it. To do.
it's better. Cool.
Negotiated protocol is mutual. Okay. I'll highlight that part. Negotiate.
Sure. So my highlighting kind of sucks, but we see that negotiated protocol is the one we expected, and negotiated protocol is mutual is true. So we should test both those things.
Yep.
Don't want to type this twice.
And so what we're going to do in reality later probably is like, we already have this TLS connection set up, so we should probably like give it to the fallback one, but the fallback one is going to want to dial it itself, but we don't want to make another redundant TLS connection, so we probably want to, if this fallback one is a type we know, like the HTTP transport, and it doesn't have the dial TLS or dial function already set,
sub in our own.
sub in our own dialer and then have a pool of free connections and then immediately hand that connection over to it, so we're not wasting.
Weird. It's cool. Kind of gross.
Or something.
Yeah. Could not negotiate protocol.
And put a to do, like fallback to HTTP nicely without new connections or something. I mean, that's really the same comment as the one above it. You could just make this condition up there. P does not equal next protocol or not. Next one is.
But then this error f will be wrong.
No, just make the error f just being like not HTTP2. But it's fine.
Let's just leave it for now.
Yeah.
So now we actually have a connection that's.
Well,
HTTP2.
let's run the test again and make sure that we get to do. Okay, so we're now throwing away connections to google.com and.
Awesome. So now we have to write a request, right?
Yep. I'll type for a while.
Okay.
So, the first thing you're supposed to do is send. Well, we can look at the HTTP2 server and see what we expect. In handle con, when we get an incoming connection, there's a bunch of stuff about checking the TLS and stuff. Then we go into serve, and in serve, the very first thing the server does is send its connections, and then it reads the preface, and read preface, we expect within a certain amount of time to send the client preface, which is this string here. So we have that constant.
So we want to write that out?
Yep. So I think back to the transport. I guess the first thing we do is what was it called? tcon. Tcon write client preface. I have in here the public one. The const that's public is a string, but then there's I needed for other reasons the byte slice one, so I have that privately there.
Cool.
So
for other reasons.
For other reasons, I forget. I thought it was a good idea once. Okay, so we write that.
Cool.
And now the spec says, you want to switch to the spec thing?
This one?
Yeah. There's a section like starting it up.
Is it? Oh.
You go to the table of contents at the top. You send a settings thing.
Stream.
Search for starting HTTP. Yep. For HTTPS. So skip the normal HTTP one, because now nobody does that.
Nope.
Yep, starting. Okay. So with prior knowledge, nope, connection preface. So we sent that. That's the hexy version of the thing we just sent. And then we send a settings frame.
Okay.
So we need to make a framer. So we already have in frame.go, we have this new framer. So we're going to make one of those. And I guess for now, we really should be writing to a buffered connection rather than.
Well, let's set it up. Just a buffered writer.
Set a buffered writer. Okay. Buffio new writer of the tcon, and I guess we could do the same for Buffio new reader of the tcon, and we'll be writing to that, reading from there. And so in the settings package, there's a bunch of stuff like framer write. Yeah, okay, I don't know what I'm doing. Let's go over here.
I have no idea what you're doing either.
Yeah, it's okay.
Are you trying to figure out how the framer works?
Let's try the signature of the. There's a whole bunch of write methods on framer, like write settings act, write ping, write go away.
So is it settings that we have to write now?
We have to write settings. Write settings, and that just takes a whole bunch of settings. And there's I think that's in here. A setting is a setting ID and a value, and then all the settings are up somewhere else in here. Type setting. Yeah, and there's all the setting IDs. So this is basically where we the two sides negotiate like how much stuff they're allowed to do.
But do we need to send any settings? Can we just
send you always need. You can send an empty one.
Yeah. So let's do that.
Let's send an empty one. So for write settings, we could, but well, I guess this whole thing is like care. Yeah. And then that's just written to our buffer.io writer. So at this point, we have to flush it. And I guess
should we check errors? Is it yes?
Yeah. So yeah, we'll probably want to do something later where we have something that tracks all the errors.
Mm-hmm.
You know, make the writer keep all its errors stickily, and then we could. And yeah, this will get tedious, so we'll change this pretty quickly. So at this point, the server should say something to us too. So we should, there's read frame. Yeah. And then that's just read frame.
And then we can print it out.
Yeah, read frame.
See what it says.
I guess we could return that directly, but got frame F. Now you want to run the test?
Sure.
You know, Control L, move it to the top of the screen.
Yeah. We got a frame.
So we got a settings frame. That's not very beautiful. There's a better way to do it, but okay. Let's go back to the code. So let's switch on the type of that frame, and I mean we're pretty sure it's going to be a settings frame. Settings frame. And now there's a method, I think, on settings frames called like for each. Oh, it's in frame.go. For each setting.
Ooh.
I know. So we can setting and won't return anything.
So just enumerating the settings.
So let's try that. You know, we could do something useful with this.
Oh, max concurrent streams 100.
So this is Google is saying for any HTTP2 client connecting to it, we can have 100 HTTP requests outstanding on that one HTTP or the one TLS connection. So we have to remember these things because we have to tell our framer, for instance, that it can only do that, which is the default value anyway.
Okay.
But for instance, when we do more than one request per connection, we'll have to remember that 100. But I think for now, these are all default values except for 100. So we can just ignore this.
So we should just put in a to-do to actually care about the settings.
Yeah, to-do.
I mean, what will we do? Have struct fields for these various values and pluck them out individually, or?
Yeah, we'll have to pluck out the ones that we need to respect.
Yeah. Oh, so yeah, you're gonna copy them?
Yeah. Yeah. Okay. So now basically the flow of HTTP is after HTTP2 is after the settings frame. Now we're basically set up. We've read the settings from them. We've sent our settings. And so now we're just in this idle land where we can send as many requests as we want, or up to 100.
So we're in this pod. We can begin exchanging frames.
We can begin exchanging frames. So the basic flow is we're going to send our headers, and then I guess if there's then there's maybe some data if there's like a post body, and then so we send headers, and there may be.
But isn't before headers like the actual request, like
no header,
or does that include the headers?
Headers is like everything. So
it's not HTTP headers.
It is HTTP headers, but it's also all the metadata about the request, like the path, the authority.
So in HTTP2, that is headers.
Yeah, there's magic headers that start with a colon.
Okay.
So we'll have to write those out in a second, and then after that, server sends same thing, headers with optionally a continuation. So a continuation is basically another frame of headers if the headers didn't fit in the previous, because you can only write certain size frames. In practice, that won't happen. Well, maybe with 16K ones.
Does the framer not take care of that? I guess.
No. The framer is pretty.
It's just dead simple.
Yeah,
just reads, writes frames.
Yeah.
Cool.
Actually, no. I may lie. I think I did add a convenience thing for that. Let's see. There's it's a single headers frame.
Oh. Encoding headers and splitting them into necessary continuation frames is handled elsewhere.
Elsewhere. I know, for instance, in server test, there's tests about continuations, but I forgot what did that. I don't think we have anything.
Holy testing, Batman.
Holy testing.
What portion of the HTTP2 packages tests?
Like 2/3 of it.
Yeah, that's cool.
Okay, back to transport.
So what's a headers frame param?
Oh,
That's
okay.
what we need to be writing, right? We need to turn our request headers into...
Type headers frame param. So this is stream ID. So that's every request has a unique number that goes up. And block fragment is the encoded headers. It's a special compression format. I should probably say in here. Of an HPAC encoded header block. In practice, this will be all of it. End headers is set to true if it actually fit in one frame. Otherwise, it's set on the final continuation frame. And then end stream is set when we're done sending body. For a header, if there is no body, if it's a GET request like it is for ours, that will just be true. And path length is used to obscure basically how big your requests are, but we won't be using that here. And priority is for if we're telling the server the order that we want the responses, like maybe you want the CSS before the JavaScript, or JavaScript before the CSS, or whatever. So these are all parameters to write headers that sets all the right bits and writes out all the stuff.
Okay.
So the first thing we need to do is encode the headers.
As headers frame params, or as block?
First, we need an HPAC encoder. So there's a subpackage to HTTP called HPAC, and it has an encoder, and it has a new encoder. So I think the first thing we'll have to do is up here when we make our framer. Eventually, these are going to have to go onto the transport, or onto the. We're going to have a client connection type. I mean, we could do that already. Do you want to do that already?
Let's just do it the dumb way first.
I think we'll save time by doing it this way because. So at this point, things are good. So let's make a client connection.
Just call it client con. I guess it doesn't matter.
Client con. And we'll keep the tcon on it. Maybe up here we'll actually define this thing. Struct tcon buff.io writer, buff.io reader. Then we'll have our framer. We're going to have a buffer that our HPAC writer encoder writes into this, and we'll just reset it. Yeah. And then we'll have our HPAC encoder. So here we'll. I guess we can send this one right away. It's kind of boring.
Yeah.
So I think for all this reading and writing error stuff, we should probably have a writer type that keeps it sticky errors.
Couldn't just write on client con be the writer type?
Well, I want like the buff.io writer and the framer and all this stuff. So whenever there's a write error, to keep that sticky, so we can check that very rarely, and it'll accumulate the errors.
Right.
So I think if we have like a some type that's like
error writer or something.
Sticky error writer, and
and the writer, of course.
IO writer, and it just does something like
straight out of the blog post. Rob wrote a blog post about this.
Oh, well, maybe he copied me.
Or maybe it's just not novel.
Maybe it's not novel at all. So I guess if there's been an error already, we should just like stop.
Return it. Yeah.
Oh yeah, we could just return the same one.
Yeah. A SU error.
It's a swear. I don't know why I spelled that all
It'd
out.
just be W.
Well, we already have a W.
What's WW?
I'm glad you're amused.
SU.W.
Yeah, okay, there's already a lot of W's. Right, P, and well, we know that's not there, so we can just do that. Oh, sure.
Yeah.
Okay, so we have a sticky error writer.
So maybe when we set all this up, where are we setting it up?
Down here.
Yeah.
So we
We
want.
should just do the buffer writer and reader inline in the struct.
Maybe buff.io error writer should take a pointer to an error. And then we could put the sticky error in the client con. We could say like first write error that has occurred.
Okay. I can sort of see where you're going with this. You need to change all the other stuff. Put a star in there. An asterisk.
Good enough?
Well, not good enough. It's correct.
Well, does this make you happy?
I don't know. You're the one who wanted to change it.
Okay. So now when we make our buff.io writer, this is a sticky error writer, which no longer actually has to be, we no longer need this. We no longer have mutable state, so it doesn't need to be on a pointer.
Ooh.
Sticky error writer, and we
Tcon.
Tcon. No. Oh yeah, it's Tcon when it finally flushes.
And cc and cc.werr.
Okay.
Do we need to put the buffered writer inside the?
Yeah.
What's with your syntax highlighting? Why is it gone green here? Can't do that because we're referring to the same CC.
Okay. CC buffered writer.
You can
CC framer equals.
just make this one cc.bw equals that.
Which one?
Just delete that and put that there.
Oh, I see.
And this should be Tcon.
Tcon. Okay. So now we'll be able to do things like just blindly write settings because things checked, and now we could even do stuff like now we could just also blindly flush it, which is CC buffered writer flush
And cc framer write settings.
and also on our
Hang on, you didn't fix it. CC framer. Just above flush. Yeah.
Oh. And then we'll just occasionally have to do something like if WR equals nil, we'd do 1. And we could, wrap this in something that, if this comes up a lot, which probably will, panic and catch it somewhere and just return it once.
Maybe. Yeah.
All right. Test that this still works.
It won't. You need to do cc.fr and read frame as well.
And let's now we can go over some of these settings, and if it's certain ones, like if what is it? The setting is, I think it's called ID. s.id equals, the one we care about is max frame size. So that, then we'll write max frame size equals s dot, I think it was called val.
What does initial window matter?
Type client. Settings from peer, max frame size.
Are they called peers, not server?
They like to call them peers in the spec.
Okay.
Okay. So we have now to write some headers. So we have that.
Can I
yeah.
All
For
look, let's see if the syntax highlighting looks.
it's fine.
Yeah. Now that people are used to it, okay.
You just don't want to be ugly.
Fine, I'll turn it off. I don't care.
I want it on.
We should test that it works, actually.
I got used to the pretty.
We should test that it works. Nope.
Nope.
Type int.
That's what my niece says when she opens doors that don't go anywhere. Nope. Oh, 0. Return 0.
Cool.
Perfect. All right.
I'm just going to quickly do this because
there will be more.
yeah, and I don't want to log.
And for the default case in there, say unknown something.
Well, yeah, that's what I want.
Unhandled. Turn on the pretty.
All right, fine. We got a lot of comments about syntax highlighting or the absence of last time. I don't really care about syntax highlighting. Some people do. All right, so now we need to actually write some headers after that big distraction about error handling.
Well, now we can use methods and stuff and not be in this one gigantic function. So.
All right, so we can say cc dot write headers.
How about something to return? Let's make a function that returns a byte slice. Byte slice in an error. Called like let's call it encode headers. Or yeah, encode headers. And it takes a request and it returns a byte slice and error.
Does it need to return an error? Yeah. Let's just do that for now.
And okay, so now we have that buffer on client con already. I called it hbuff above.
Yeah.
So reset that. We're gonna reuse its memory. And we already have our hpack encoder. Oh, we never made the hpack encoder. That needs to be up above. I think it was embedded, so you have to be a pointer to. No, it doesn't. We're not writing this out. We're writing it to a buffer first.
Oh yeah.
If the encoded headers end up being over 16K, we're gonna have to cut it up into chunks and send the header and the continuation frame.
So is it hbuff?
A pointer to hbuff because it was embedded in.
Okay. And that's the 0 value.
Or
so
not embedded, I guess. But.
Yeah.
Yep. Okay. And so now.
So now we need to actually hank encode something, I guess. What's hank?
Okay, switch over to my screen. I'll show you. There's this. This is the hpack encoder. It has a write field, and then there's I guess it's in hpack. There's this header field that has a name and a value, and a sensitive one. Sensitive means don't compress this and don't
Don't split it or something. thing?
This is for that crimey beast attack thing where you can like derive people's cookies and passwords by altering nearby things and trying to see how it compresses and stuff.
Oh.
So this was the mitigation for that, or part of the mitigation for that.
Ooh.
So we'll ignore it for now.
All right, so we create a header field for each header that we want to send.
Yep, but we have to do certain ones first. There's some magic ones in the spec. If you switch to the spec, search for like :authority. Just search in page for :authority. Yeah, so these are the magic ones. So we send the method, the scheme, and I think these are...
Okay, well, we can start with method.
Okay.
So do we need to create a slice of these things? Or
No, we'll just call right...
What is
Each
the
one
header
you call
field?
right field, right field, right field, right field.
Okay. So cc.framer.write field, and it is what is it? It's a header field.
And with a name and a
key.
value.
Oh, name? Okay.
They're called name and value.
Yeah. So the name is scheme. No. Method.
Method. And
Val or value?
Value.
And this would be rec.method.
Yep. And so in HTTP2, all headers are lowercase, but I think this one is still uppercase.
No. Oh, you mean the
value.
The value.
Yeah, I thought maybe HTTP2 would make that lowercase also for consistency, but I don't think it does.
That looks like an old RFC.
It doesn't say anything. Yeah. It's fine.
Yeah.
And you don't have to check for errors here because it only returns the underlying writer's errors, and a byte buffer never returns errors. Oh, you like this from the other day, huh?
Well, no, I do this too, but I like this in this instance. Just create a little helper because we're going to be writing a bunch of frames, fields.
That doesn't really need to be a closure, but it could be. It could be its own method on client con.
Let's do that.
Okay. Dimitri's latest escape analysis changes means that wouldn't allocate though, because it would capture the receiver by value. Okay,
that's cool.
And don't return anything. Okay.
And now this becomes cc.writeHeader. Look at that.
Look at that.
Concision. So method and then scheme.
Just set that to HTTPS.
Lowercase. Yes.
Yep.
And the next one is authority.
That's like
the authority portion of the URL. What is the authority
clients
portion?
that generate HTTP2 requests directly should use the authority pseudo header field instead of the host header field. There you go.
So this is our host.
Yeah.
So, we've had a host before.
Well, rec.host.
Ah, yes. Perfect.
But our docs, the Go docs say the request host is the one to send to the server as the host header. Comment this out for now, that line, and put a to do at the end, and I'll read the spec later to figure out what we're actually supposed to do. For now, let's just send the host header as the host header, which is what every other client seems to be sending to me in my HTTP server. No, it's not a pseudo header. It's just a normal header. So,
like that.
Nope, it's just going to be normal. It's going to be part of our thing. So we need one more pseudo header. We need the path, which is the final one. And that's what rec.url, the path. Perfect. And now we need to enumerate all the headers in.
Yep. Rec.header, or is it headers? No, it's header.
Yeah, header.
Well, actually, I have the HTTP.
Yeah, it's just
request.
Header.
Header, and a header is just a map of strings to slices of strings. So
I always call that one V, or
so
that,
that's, well,
yeah, key, and I call that one VV. So K and VV,
And
and like a vector of values or something. Yeah.
And now we have each V and a VV. And we can just write K and V.
Nope. K has to be strings to lower of K.
La-di-da.
And put it to, I don't know. We'll probably cache those or something, so we're not having to generate all those, but later.
Yeah.
Once we benchmark.
Yeah. Lots of optimizations.
Lots of
This is not optimal.
Okay.
We should probably check our write error, right?
Nope.
Are we still going?
We haven't written to anything that can fail yet. We're only appending to memory.
Oh, yeah.
So
this is writing to...
It's writing to our hbuff.
But we're calling the framer to write the field. The framer is...
No, that you should be calling... this should be on henc, your HPAC encoder.
Oh, that should be like that.
Yeah. Which henc writes to hbuff that you reset at the beginning of here. Okay, so now, up here where you say write headers, you've written it out in memory. And actually, you're right.
I got to return them.
This doesn't have to return an error, because there's nothing there that can fail.
And then this should return hbuff.bytes.
Yep. Okay, so now up here, we need to...
That's a terrible variable name.
So here we we're going to loop as long as there's more than 1 byte in headers, and we're going to cut off chunks at the beginning, like cut off 16K. So 0, greater than 0.
Oh, sorry, I thought you said as long as there's more than 1 byte, but you mean as long as there's 1 byte.
Yeah. So now get our chunk. Why don't you say chunk : equals headers, all of it, and say if len of chunk is greater than the cc.max frame size, then bound your chunk.
Chomp the chunk. I believe that's what they call it in the industry.
Okay, and now we also cut it off from headers. So say headers equals len of chunk : Okay.
I like these.
Okay, so now we have to write either...
With the framer?
Yeah, with the framer, we're going to write either a headers frame if it's the very first one, or a continuation frame if it's not the first one.
Okay,
so first, okay?
Oh.
So if first, true K.
The syntax highlighting is throwing me off. cc.framer.write.
Right headers?
What is it? Right headers. And that takes a header frame
headers frame param.
And let's see what that is.
Stream ID.
Oh, so what is our stream ID? Do we have one?
1.
Should it be odd or even?
Yeah, so why don't you call cc.next stream ID? It has to be odd for clients.
Should I be storing this somewhere though?
Yeah.
Oops.
Well, we're doing a new HTTP request per request. Let's just hardcode 1 for now.
Yeah.
It'll always be 1.
Well, I'm just going to write the function. Does that make sense? Oh my god. Day after FOSDEM. Is int alright? Do they get bigger than an int?
Oh, and I made another video about the HTTP2. Speaking of FOSDEM, I gave a talk at FOSDEM about the HTTP2 server. So people who like this video also like my FOSDEM video.
You may also remember me from videos such So stream ID, we're storing the stream ID in the next
One.
stream ID.
1. Just write 1.
Stream ID. And then we also need the block fragment. This is it.
Okay, what is your stream ID up above though?
It's next stream ID.
What is that? What type does that return?
Int.
No, uint32.
Well, I was asking you about that.
Oh, I was busy reading my email.
Really? You shouldn't have your own laptop. That's bad. All right. And if it's not first, we write.
Here, block fragment is chunk.
Should we call it block? We've already used chunk. And
end stream is equal to len of headers equals 0. Oh no, sorry, that's end headers is equal to that. Not end stream.
So end headers, right? And end stream is what?
That is whether there's a request body or not. So for gets, it won't be anything. And for everything else, we'll basically look to see if.
Well, we can say has body is false for now.
Okay.
And then
to put end stream equals not has body.
And then what else we got? Oh, was there nothing else we have to put in that headers frame param?
Nope, that's it.
And
now we say see write continuation.
oh,
And that's a stream ID. And end headers, which is that one. Oh wait, that's len of headers equals 0.
oh yeah.
So same thing. You can put in a variable if you really want. And this is the chunk.
I'm gonna do it.
You're gonna do it.
Oops, I know I misspelled that. There you go.
And then the chunk.
Cool.
Perfect. Okay, so we've written a request.
And that's a for loop. So now should we check the error?
Sure. Oh, before you do that though, flush it. Okay. Now we're going to read the response for them from the server.
You know, we could have just checked the error when we flush and not written that little error handler, and that probably would have been fine.
No, because it can.
Oh, we don't
flush
always
on
want to flush.
No. If we write a whole bunch of stuff, like imagine this was a, 16 meg of headers or something like that with tons of continuation frames. The flushing can happen on its own, and we'll lose that error.
I see. Cool.
Okay. So why don't you read a frame and see what we get? We should get a headers back from Google. So
Okay.
it was up above that f comma error.
What? Oh yeah.
Back when we got the settings. That's probably enough. Do it after the comment.
Yep.
Okay. Let's try it. Right. Almost.
I think it's called right header, not right headers. Oh.
Encode headers. You called it. Didn't you call it
yeah.
Encode headers.
Yeah. I keep wanting to use. We've got a different key combination for screen as well that I'm used to.
What's your screen meta key?
Control A,
Oh,
the standard.
that sucks. Screen knocks.
Look, it's. Oh.
Slow. Oh, yep. Gotta.
Well, maybe max frame size should just be an int.
No, I went through this with the
you
server
did?
side. Yeah, that's fine. That's good.
What do we got? End headers. Oh. capital right header. Oh, what? Framer has no method right header.
It's called right headers, I think. I use the same names as the spec.
Yep, that's right. Now, no new variables, that old chestnut. And header field.
HPack.
Oh, it's hpack.header field.
Yep.
Got frame. What did we get?
What did we get?
Frame header.
Oh, we got a window update. So HTTP2 is flow controlled. So they're giving us some tokens so we're allowed to write.
Okay. What?
Yeah, so the way we'll actually structure this later, since they could be sending us crap anytime, that not necessarily what we want to expect, that we're gonna have to have a Go routine that's running, reading stuff, and just adjusting to stuff as it goes.
Right. So this is the part of the code you said we probably end up throwing away.
Well, no, maybe it's time probably at least to write the reader Go routine now.
Reader Go routine.
So after you read that initial frame,
Which this is the second frame.
after you read the settings frame up above before we send our request,
Mm-hmm.
because this is the only one that they really have to send us,
Mm-hmm.
and so you can get rid of the switch. You can actually do a test to see if it's a settings frame, and if it's not a settings frame, just they violated the protocol. I would say SF, OK, and SF's all right.
Okay. If not okay, return nil. I guess for now.
Percent or capital T. All right, and now you can just do SF for each setting. Yeah, that's fine. Delete it.
And then I'll just put. I'm gonna give you these to do.
All right, thank you.
Cool.
Okay, so now start up our Go routine for the reading. So we have our CC. Yep. And well, because it's a single request, later we'll do multiple ones. Now we won't shut it down. Okay.
Good old infinite for loop.
Infinite for loop. I put a comment runs in its own Go routine above the func. It's kind of a convention I did for the other one, the other server. And so read a frame. You want me to type?
Sure. Let me save it. She's all yours.
Read frame. So I guess if we, well, we'll just log it for now, but really we want this to notify that there's been an error, so we kind of want to defer here that maybe defer that the reader is done,
and we'll set some error, reader error.
Yeah.
Rrr.
Set after reader done is
Before.
Oh yeah. Before. So when we make our client con, we'll say reader done.
Oh,
Yeah.
I'm missing a closing parent.
Reader done. And so now I guess you could say cc dot. Did I call it reader error?
Yep.
Okay.
I did.
So for now, let's just print everything that we see. Brad A. Dun, dun, dun. I think it's frame header.
You've got %VV in there.
That might be redundant. I forget how these things stringify. So.
And then we've got a read frame here and another read frame which you can delete.
So let's do this and just block forever. So this won't return, but at least we'll see what Google's sending.
Yeah, and there's another read frame up a bit higher. You can kill this too.
Where? No, there's only 2 now.
Oh, where did we start the Go routine? Oh, after reading the settings frame.
Yeah.
Cool. Or delete that got frame log message.
Which one? This one?
Yeah.
Okay. And we'll say that this is read this.
They capitalize frame names but not headers. Yeah.
Who knows? Oh, they can't see my running tests.
Oh.
Back to the other screen. Frame. A frame is just header. Okay, let's go run tests. Look at that.
So we got more than one.
We got a Windows update. They sent some more settings. This response headers to us, the data, and then just in case to see if we're still there, they pinged us within a millisecond.
Oh, that's nice.
Hi. So
they actually sent us data. Is that the full response body there? Probably.
Yeah, there's probably here we can here, let's print it out.
If it's
then we can call it a day. So instead of logging all that stuff, we can switch on .type, and if it's data frame, then in frame.go there's
data.
There's stream ended and data. So we'll say data f.data, and then
does %q stringify? Is that like %s?
For byte slice and strings, it does the same thing. Okay, switch to the other screen. What did we get?
We also got
ping,
headers.
Data headers. Okay, so we'll also log headers. Headers frame. This is HPAC encoded, so we also have to
HPAC decode.
HPAC decode.
So, but we don't have we need a read HPAC buffer.
So I'll show you some craziness here. That's what we're gonna do. Type cloud. We don't need that. HDEC. This is HPAC decoder. I will rearrange the struct later to make sense. I'm trying to make sense of it as I go, but then I gave up. New decoder or something. So it takes a max size, which we get initially from once we get the settings packet from them. Then we know how big, based on what we told them that we can do and what they decided to do, we would make a decoder of the right size.
And then it has its own buffer.
It deals with that internally. So back in transport, when we make henc, we'll also, after we get the first settings, let's just assume figure out henc size. But for now, we'll say henc equals hpack new decoder, and
CC max frame size.
I have something like default, what is it, max read frame size, initial header table size. I think it's that. So we'll just assume defaults for now. And then it wants in here, new decoder. Oh, HPAC new decoder, a function that takes a header field. So we'll call this like on new header field. And then client con on new header field. So what it does is it keeps its little state machine of decoding crap and keeps a fixed size buffer. And when it has a full key value pair with a sensitive bit optionally, it calls our thing and says, here's a header for you, here's a header for you.
So how do we hook this up to the read loop?
Channels, probably. No, it won't matter because these will be running the same Go routine. So when we get a headers frame, clear some state, and this method is called, and we update some. We'll just hang our slice of headers or the thing we're building off the client con. Yeah. So
this client con is becoming like request specific now. So it's gonna have to.
Yeah, but for a given TCP connection, like. Yeah, I guess we'll keep a track of. Well, so the headers and continuations all have to be contiguous on the wire. So while we're reading in, we'll keep track of whether or not they lied and their stream ID switched.
Mm-hmm.
But otherwise, we can have one header, request header, response header, or I guess in this case, it's a response header that we're building at a time. And once we have it fully built, then we give it away and then we build a new one next time. So for now, we'll just log it. And so here in headers frame,
we get a frame header.
We get a header block fragment. So we, in our henc, we write, I think it's write.
What do you mean by not owned there?
So the framer, when it reads stuff in, it gives out frames that have a bunch of accessors to get at stuff, but you only can access that memory until you read the next frame.
Right. And then that's what is valid is all about. Yeah. If this doesn't make sense, you really should watch Brad's FOSDEM talk about HTTP2. We should definitely link it at the start.
And so the way the decoder works is you write into it. You just write into it, and it calls your callbacks as it gets a complete thing. So we'll write into it the header block fragment that we just read. And likewise for...
don't we want to write into HDAC, not HANC?
Yes. HDAC. This is a continuation frame. To do verify stream ID is the same. And we'll want to do stuff here like if headers ended, well, maybe we'll just log it. And likewise for this, that's at that point, we would have the complete response thing, and we would be able to start reading data frames or whatever. Okay, let's switch over and see what this does.
Did you run it?
No.
Oh, you want me to run it?
Yeah.
Cannot use HPAC new decoder.
Oh, I copy pasted a little too quickly. No. HDEC.
It's when you're creating it. You probably did cc.hanc.
Yeah. Okay. Back to the other one.
We've got status field,
I like
content
header
length
fields.
field, content type, date, server,
Where's our data?
Google front end.
Bad request.
Why is it a bad request? I don't understand. I mean,
But we didn't. I bet we didn't send a host header, which HTTP 1.1 requires. The old. Let's try adding a host header. I bet that's the only thing.
didn't we send a host header?
No, we did it here. So if they didn't send one, so let's do this. If and there's not one, then we will cc write header host. Note the lowercase.
Yeah.
Okay, we did strings.lower there.
Yeah.
And then we'll just say rec dot host. Well, it could be URL dot host. So this one takes precedence.
If it's empty.
And if host is empty, then host is rec.url.host.
What?
This is what we've documented for the other one.
Oh, no. Yeah, I know. I was just reacting to the green.
Oh, okay. Let's switch over to the other one. Let's try it again.
Still a bad request.
What are we doing wrong?
Do we need to send an authority?
Try it. Okay, try again. Nope, that's not it.
Wait, let's look at the spec. What does it say? Path. Okay. Method scheme authority path.
Maybe is method supposed to be all lowercase? Let me look at the server.
Oh, look, examples.
Okay, it is capitalized.
Get, HTTPS, path, host, accept. Do we need accept? No, probably not.
Scheme authority. Let's log what we're actually sending. And actually, a better place to do this is here. Oh, I bet we're not. We may not be flushing. I don't think you have to flush this.
Flush what?
HPAC encode.
Oh.
Oh, I guess not. I thought maybe this did some buffering, but it doesn't.
No, because you're always going to be running to some. Oh.
Okay. Okay, let's run it again and just see what it's doing. So we're sending method get scheme HTTPS path host.
Do we send anything after these window updates and stuff? We don't, do we? So there's no reacting to any of that anyway.
No, and if we were violating HTTP 2 at this point, they would just hang up on us.
Huh.
Well, let's see what other packets or what frames they said. Window update gave us 1 bazillion tokens on the connection. The ACTR settings.
And then the headers look. Well, that's the head. By this stage, it's already.
Yeah, it's the correct.
Do we don't need to act their settings, do we?
We do need to act their settings. But we can do that, any amount of time later.
Okay.
All right, let's do it now. It's one line.
What is the window update though? What do we need to handle that?
Maybe we have to act their settings before we. I think
Okay.
I think that's
let's try that.
Transport. Go. Where's our little read loop? So we've got their settings here.
Yeah.
And done. And I guess we'll flush it. And I don't really care about the error at this point. We'll catch the sticky error later.
Yeah.
Switch over to the other thing. Nope. Really, they should have hung up at us for not hacking the thing before we sent more things, but. Well, this is the anticlimactic way to end the video. We're so close.
Well, I mean, it's saying bad request, so it's in response to the request we're sending, not necessarily. Would it say that if we send a bad HTTP2, like if it's a protocol error, it would be something else, right?
Let's go to the tests. Or here, I'll go to the tests. Let's instead round tripper, and here we'll say oh, we can actually just do res right.
And you want res body in the next line. All right, see.
Okay, switch to the tests. All right,
so it works.
There's nothing wrong with the request. Hey, maybe we should just be implementing Quick.
What's Quick?
It's like the crazy protocol over UDP with like that merges Speedy and TLS and replaces TCP and everything.
What? Cool.
No, it'll be a lot of work. I'm not even looking forward to writing the Go implementation of that.
All right.
Okay, well that works.
This is disappointing. Let's look at the code again.
Okay.
What about they send us that window header? Does that matter? Like, are we sending blocks that are too big or something? The window update?
Yeah, but then you would think they would just hang up on us rather than
send us a.
Yeah, and also like what they sent here, there's a default window size of 64K, and then they just said, or that's the default per stream, and they said here, you're allowed to send like a ton.
Okay.
So they don't seem to care.
Do we need to do the window update or something?
Nope. Streams is fine. Initial window size is the default.
I mean,
maybe should we not send scheme HTTPS?
What are the schemes here? In this example, they're all HTTPS.
Oh, wait. Oh, that's their content link that they were sending. Path host.
Oh, we say. What do we say?
I'm looking at the server's implementation to see if anything reminds me of. Path scheme authority. I should have just done that to begin with. Oops. I don't know how to actually send yeah. What? Well, we'll ignore that.
We'll just cut to us finding the bug.
Yeah, but we won't because we're lazy. Yeah, I don't know, man.
Let me see.
The server's not too useful. Bad request.
So, I mean, can we dial our own HTTP2 server?
We could. That would be sensible, and see if our own server one replies. Or we could. Do we know anyone else who's running an HTTP2 demo server?
We could hit HTTP2.
Oh yeah.
.org.
Yeah. Let's do that. Okay.
All right. I'm I'm already there.
You're already there. Unhardcode that ipappspot.com authority.
Okay, that's something. See, this could just be host, and then I can hoist the host header out of here.
Yeah, no, you deleted my comment. Oh, move that comment up, that to do, because I don't think you're supposed to send both.
Oh.
But if it makes you feel good for now. Sure.
Well, what?
Or you can always keep it.
I'll keep
Just
my
run
hands
it.
off.
Let's see what happens. Move it to the top. Well, that works. So,
Shouldn't have changed anything.
well, switch it back. No. Keep that. But change the test to hit Google now.
Oh yeah.
So let's go back and dwell on our success for a second.
Hang on. Oh yeah, okay.
Look at that. It's an HTTP response.
Yeah. We could even make it return it as a reader for the response body and make
No, it's in a
round trip work.
separate Go routine.
That's fine. We can look. We've got like. Let me just check how much camera time we have left. We got 15 minutes of recording time. I reckon we should just plumb it in and make it actually work.
All right.
So
You want to try IP app spot? See if that was the difference.
Sure.
Make it a flag. Is the difference a trailing slash or not? It wasn't that, I'm sure.
There was a trailing slash in both.
Okay.
Bad request.
GFE hates us.
Weird. Okay. So this is going to be funny. We have this read loop going, and at some point it gets a data frame. Well, actually, we get a bunch of response headers.
Okay, we need to accumulate the headers as we go.
So, do we need to have something that's like the response?
No. So this has to be on client con because we're gonna have to like access it from another Go routine.
Yeah, but I'm saying we could populate the response and then send it over a channel to the.
Yeah, and we should probably in this one like write to a pipe or something that the other one reads from.
Oh.
Because eventually we're gonna be getting data from lots of different responses, right? We're gonna have to like feed it to our clients.
So maybe the read loop here should take the right end.
Nope. Okay, go up to client con. The type.
Yeah. Nope.
Okay, so this needs a field called http.header, which is the header that we're building for the next response. Call it like next res or something.
Is it a header field or a response field?
It is the response headers that we're sending.
Okay.
So, and now back in our on new header field down below. Okay, so first, when we get our first headers frame,
we make it.
we make it.
What did we call it again?
Next res.
Next res.
All right.
Cool.
And then
And when we end headers, we need to do something. But
send it on a channel to somebody and make a pipe pair for the body and.
Yeah. So we want to headers add.
Yep.
cc.next res.add f.name f.value.
And then wrap f.name and http.canonical header value. Or is it just canonical header? Oh, sorry, it's just canonical header, I think. Sorry, canonical header key.
Oh, well, that makes more sense.
It does make more sense.
Cool.
Right?
And now we need to signal with a gate or something.
Okay, where was this a Go routine? Well, we'd probably have to like look up the receiving channel based on stream ID and send it to the right person. So go back up to your round tripper. the round trip function, and where we were like saying like sending stream ID 1, you probably want to make a. Where are you sending stream ID 1?
Yeah.
Next stream ID. This should probably return. There's probably a method on CC called like new stream, and new stream returns its own type that contains all the channel crap, and it contains the ID
And the headers. Probably.
Yeah. So why don't you call this like, and we'll call the type like client stream or something like that. Wraps all the stuff. So call it new stream. And then call this thing like, call this like CS or something. And let's go write the new stream method.
Whoa. So this has ID and headers.
No, ID is a uint32.
Oh.
And it'll have it'll have like chans between crap.
Okay.
Like a chan of the response, basically.
Okay. So. Oh, so this is.
And it'll need a mutex to guard like the next ID. You can get rid of that whole method, or you just take it over.
Well, I'll use it in this method.
No, I don't think so, but maybe. Client stream, okay. Mutex, this is going to be called from lots of Go routines. Yeah, I'm sure. And then say like, stream ID equals, whatever it is, the cc.next stream ID.
What, isn't this now
Or
like that?
Sure. Yeah, I mean, you're going to have to increment that by 2 every time because to stay on the evens. So when you first make the client con, why don't you set next stream ID to 1 or set it to -1?
Well, it won't be a method, it'll just be that.
Okay, but you also have to increment it by 2 or something, plus equals 2. And so set it to -1 to begin with so it starts off being 1. And add a mutex.
Wait, did I just delete something? No.
It's
Next stream ID, uint32?
Yep. Oh, well, now uint doesn't work very well for setting -1, but whatever. So increment it plus 2 at the end of your thing. Set it to 1 now when you make the client con.
Where do I make the client con? Here.
No, can't be negative.
And then here.
Okay. And make a field dollar called like res_c for the res channel, and make it of make chan of http.response buffered of size 1, pointer to http response.
Oh, so we are going to use responses now.
Yeah.
Okay.
And that make it buffered too.
Yep. Is that
Okay.
it?
Yeah, so that it. And put the chan on the type.
Okay. We're getting somewhere. So now.
Okay, and now, that new stream will also have to register that stream ID in a map, so the other guy can look it up.
Okay.
So,
Streams.
Yeah, streams.
Map uint32 to client stream.
Yeah. Is there mutable state in there? Or maybe a pointer to a client stream.
Yeah, it's just.
Pointer here.
All right.
And so new client stream should like return a pointer.
Well, there's no new client stream.
Yeah.
Oh, there is. There is, but in here I need to make the map.
Yeah.
And then new stream. Stop checking your email. Stay focused.
Pointer.
I need you to catch my mistakes.
Pointer.
Okay.
Okay. So now you'll need an accessor to look up a stream by ID, because we'll need this in the read loop.
Yeah. Is that
Okay, sure, whatever.
Oops. Yep.
See that streams of ID.
Okay.
And so now down in your read loop, when headers ended,
Yep.
well, and this happens on the continuation part too. So you'll probably want to be like, you probably want to set a flag and move this logic to the, just say headers ended equals f.headers ended.
What?
Okay.
If.
Well, we need the stream ID of the one that ended too. But, oh, that's in the header anyway. So you could say f.header.stream ID.
Yep. Is that right?
Yep. And it's look at the framer. Type headers frame. No, type frame header. Frame header. Stream ID, not .a.
Stream ID?
Yeah, it says you were just looking at it. Yep. Is it down a little bit more? What are you doing? You're in my window.
Ah. It was too big. I couldn't see it on my screen. Stream by ID. If
Okay.
CS equals nil. That's a terrible message. Shame on me.
To do, is really.
And then we send. Do we do new response or just construct one?
We'll probably. Okay, so we're gonna get all these like pseudo header fields and stuff like that that we've been building up in Next.res. But sure, just shove it in here for now. It'll totally be wrong. Like the status code will be wrong and the protobul will be wrong. But so that's cc.nextres. And body is
well, we get a data frame.
so why don't we just always make a body? Well, okay. Go up here.
So there should be next headers and next body or something.
Before the switch, okay. Oh, sorry. After we make a header, make a pipe pair, io.pipe, which returns a PW and PR, a pipe writer and a pipe reader. And we need to save those.
Yeah.
Those need to go on the connection state. So back on the connection state, set
What are we doing? How do we put it on the connection state?
Y'all need to set it on there. Yeah, it needs to be there. And they need to be typed pipe reader, because we're gonna have to do stuff like close with air.
Ceci n'est pas un pipe reader. Oh,
C'est vrai.
What have I done? Oh, it's this. Well, this is without a body, right? So let's just not deal with the body for a second. Well, actually, now we need to get the client.
Now assign it to your.
Well, we should get the stream, the client stream for the header straight away.
You don't know what the frame this is. They could be stream ID 0. It could have nothing. That's fine.
Oh, yeah.
I mean, that's fine. It'll just be nil. It won't crash there.
Yeah. And so here we say
the common case will be a whole bunch in a row, so we'll probably want to like not do these map lookups and mutex lookups, finding the exact same one all the time.
Mm-hmm.
Probably keep the last stream ID that this go routine accessed in.
Sure.
Sure.
And then when we get a data frame, we need to write it to the pipe.
And in both these cases, headers frame and continuation, if we see the data, the stream end one, we know that like it's end of the response or the data frame. So all three of these could mark the end of the thing. So make another bool up here, being like stream ended.
Mm-hmm.
And for all three of those, say stream ended equals f dot. I think it's called stream ended. Yes, stream ended.
Look at that. Amazing. Okay.
Oh, except for that's on headers frame and data frame, but I never added the convenience accessor to continuation frame. So you'll want to go into frame.go and add that one accessor. Search for head stream ended. Copy that.
Oh, continuation frame.
Yeah. Yeah, it's header block fragment accessor, but
Oh. Is that it?
well, you can change the type name on the after the receiver. Yep, and now all three of them have that.
Cool.
You can make an interface stream
Oh,
ended
yeah.
or
Yeah, look at this. Oh.
no, you can just do it. You could do it later after we've written to the stuff to the.
Oh, wait, it's not type. Interface. Stream ended. Bool.
Yeah. Okay.
Yeah.
Cool. Save so much space.
It's actually longer.
It is 1 line longer, 2 lines longer.
That's cool. I don't mind.
We may change.
We could do the same with headers ended too.
No, we cannot. Okay. So data is going to write to the pipe.
Okay.
So assuming
CS.pipe writer.
CS may be nil, this may crash.
Sure.
Okay.
I really just want to get the response out.
Okay.
And then,
And so then after the switch, after we've written this crap,
mm-hmm.
then we say
if the stream's
if
ended.
stream ended, then close the pipe.
Oh, that should probably happen before.
Doesn't really matter. Sure. And
then in the round trip.
and put the body on the header.
Oh.
Body equals pipe read. All right. This is so many shortcuts, but let's try it out.
Okay, so now instead of this, we have our CS. Do we have a CS?
You made it,
We
yeah,
do.
nice stream. There's yeah.
It works.
Yeah. Yep. All right. There'll be some things to do here. For instance, if the whole world goes away, if the client con goes away that we selected, we'll want to select on its death as well and return an error. Probably.
CS.id. And same here.
Your reader and writer are backwards. When you make your IO.pipe. Maybe I told you it backwards. Maybe I remembered it backwards. As reader first and then writer. Ooh, good job.
Invalid memory, null quantity reference in 261. I think you said this was going to blow up, and it does.
So headers frame creates wait, stream by ID.
Oh, we don't put it in the map when we create it.
Oh.
Yes.
Okay. Ship it. Clear the screens.
Whoa! It works.
Pipe that to left so we can actually see the headers. There we go. Look at that. Status code 0. We never populated that. There's the pseudo field status.
It works.
It works. We have an HTTP server that works against some
a client
that works against some servers.
The server that you wrote. Coincidence?
Coincidence.
I think not.
So now we have to track down Google GFE people to figure out what we're doing wrong.
Yes. But thank you very much for watching.